Okay, good afternoon, everyone. Happy Thursday. Let's get started. So after doing a preview of what computer architecture and computer systems are all about on Tuesday, we also went over basic course mechanics. We'll pick up today and start actually doing some programming. Right, so we'll introduce why we do these assignments and how we're going to do these assignments and what this is supposed to contribute toward your learning about computer systems. We'll start with some announcements. Right, this is just to kind of emphasize some things. That I didn't really get around to talking about on Tuesday, and also to provide a little bit more detail, right? So I think most of you have access to the class Canvas. If you registered late, don't worry, the Canvas for this class is public to everyone on the Rutgers network. So long as you're logged in with the RUID, NetID, you should be able to see all the content of this course. Most of the time, the material is all going to be on the modules page. So the main page that we work out of for this class is all here in the modules. My view is going to be a little bit different from yours because I have some materials from previous year here, but everything should be generally linked from the modules page. Right? If you have trouble trying to find something specific, Piazza is the best place to ask about where to find something. There is a long-range syllabus for this class. So this is the typical kind of one-page summary of what the class is going to be about. It's again also linked from Canvas. And instead of having just a copy here, I just have it point to my website. Here you can see the long-range syllabus for this class, right? So if you haven't already, give this a thorough read. It talks a little bit about the policies of the class and also what we're going to be covering, the grading scale, and a rough kind of timeline of where the major assignments and the chapters are going to be going forward. Okay, so also one thing that needs more clarification is how recitations are going to work. Because it's kind of a normal start to the semester, the hiring of our PTLs for recitations and our graders is a little bit delayed. So far, right now, we have 3 members of our core staff that I introduced on Tuesday. That should be enough for us to get started with recitations next week, starting next week, January 24th. What I know so far about who will cover which recitation sections and also when office hours are also now published on our course Canvas. From the modules page, you can go to recitation and office hour information. And here is our updated summary of who would be hosting which recitation sessions and where to find them at that time. You'll see here, there's a few things. So here's our de facto recitation times, okay? So the recitation times, everybody is registered into specific sections. But for the recitations for this class, the way it's gonna work is you can attend any or all of the recitations as you need to get the help you need for this class and for the assignments, right? So I repeat, you can go to any or all of the recitations to seek help from the TAs. You'll notice one thing here, which is kind of bizarre and inconvenient, which is that the registrar set for us 2 sections that basically take place at exactly the same time, which given this model kind of is not super useful because there's no point in having 2 parallel sessions of recitations going on. And so it's likely that we'll find a time that's convenient for the TA that's different from these times, and we'll have a different 4th time for recitations. All right, so the details of how that's going to work will be figured out going forward. One other mechanism that we'll do in this class is the recitations have a kind of focus topic, right? So some of the recitations will be focusing on the upcoming assignment, while some of the recitations will be focusing on recapping the previous assignment and giving you kind of code feedback and closure on the assignments that you've turned in. All right. And then there's one more point here about where to attend or how to attend, right? So right now, the university is closed until January 30th for in-person meetings. But starting in February, the plan, if it's safe, is that we'll have these recitations in person, right? So these are going to be the registrar designated meeting spots for our recitations. Okay.
Professor, just wondering, do we have to talk to the assigned TA we have and let them know we're going to a different recitation, or?
Most weeks you do not. So like I said, you can attend any or all of the recitations that you wish.
Wait, excuse me, Professor?
Sure, go ahead.
So because of this, we still have to go to the recitation, but we can go to any of them we want to.
Right, so this is true of all classes, right? The TAs are not going to be taking attendance. So you should plan to attend recitation as you need to get the review and recap and the help for the assignments that you need.
Okay, so it's just it's non-mandatory, but if you need it, you should go. Well, you probably should go.
Recitation's super helpful, right? So a lot of the material in more detail, the TAs will be able to give you more detailed feedback and advice for the assignments than I would be able to for the large lecture setting.
Okay, so it's not mandatory. However, you should go. It's highly recommended.
Certainly.
Okay, thank you.
So in addition to recitation, we have office hours, right? So these are the designated time slots that the TAs are offering to meet with students and have face-to-face, one-on-one Q&A. So today, just like on Tuesday, I'm going to have office hours after lecture today. Thursday, 4 to 5 will be my office hour going forward. Right. This Zoom link is not the same as the lecture Zoom link. So all of these, for all recitations and office hours, you should come to this page to get the updated virtual meeting information. And then the other TAs will have office hour time slots as well. Right. So for these, we're trying to make them so that these are not on Tuesdays and Thursdays, which is kind of when all the official times are concentrated right now. We're going to try to distribute them so that we have coverage throughout the week. Okay, so I think that's the major things I want to talk about recitations and office hours. I'll open 1 minute now, just in case there's kind of additional questions about recitation and office hour.
Professor, so like for data structures, the recitations were more like you mentioned before. So the difference in the recitations this semester for Compark is that we go over some weeks future assignments and some week past assignments. Because for data structures, it was more like review of the lecture, not necessarily the assignments that we were doing.
So I let the TAs, see what is most helpful for you, right? So every TA is going to have a little bit different style of what they feel is helpful for students. Some will be more like Q&A, some will more like be prepared recitation sessions. Some will be talking about the assignment, breaking down the assignment. Some will be looking at the assignment that was due and look at code styling, commenting, and how to write good code. Okay. Right. The TAs will see what's the best way to help you there.
All right.
Okay, so I think that's it for in terms of the logistics of recitation and office hours, right? And then, so one other thing I didn't really get around to talking about on Tuesday in terms of course mechanics is the overall distribution of where course points are coming from, right? The bulk and the most important part of this assignment, and which is also true of a lot of computer science classes, is from the programming assignments, right? The programming assignments are the way in which you learn about the algorithms, about the data structures, about the programming mechanics that you need to use, that you will need to be able to use once you ace this class. And so it represents the bulk of the course grade. Right now, it's about 77% of the course grade. And in addition to kind of you writing assignments, there is also conceptual parts that just pure programming assignments cannot cover. So typically, we would have exams to make you accountable for this material. But instead of exams, what we'll do is more frequent quizzes that are smaller and more frequent that keep you up to date on the material of the class, right? So this is like conceptual ideas, and these will overall be worth 23% of the course grade. Now, between these two, the exact distribution might change, but this is an estimate right now of what the distribution is. Okay, so I think that's pretty much it in terms of course mechanics that I think is important for us to preview now. I'll just take one kind of minute just in case there's any lingering questions about course mechanics. All righty, let's get started then. So this may or may not be the first class where you're required to be using Linux, right? Computer architecture kind of plays this role of teaching you about the hardware software interface in our curriculum, but it also plays this role of advancing your skills in being a programmer and practicing computer science. And one big part of that is to use Linux. Okay, so let's open up the kind of chat room or the mic right now for why do we use Linux, right? So what do you know about Linux and why is it important for us to be able to use it?
Doesn't it have something like a better terminal? I think I've heard before. Something like that.
Yeah, so it's textual. You access it through the terminal. I see a lot of comments saying it's open source, it's scalable.
Yeah, you can customize it.
It's customizable, extremely flexible. That's right. Right. So maybe I should break down some of these ideas, right? So what does it mean that it is open source? Right? Why is it important that it's open source? Right. Open source means that, oh, sorry. Yeah, open source means that, no commercial entity directly owns it, right? It's jointly developed and operated and kept up to date and made secure by thousands of Linux contributors worldwide, right? So it serves as this open framework for many entities to extend it for their purposes and to examine it, scour it to make sure that it is as stable and secure as it is. Right. So there's also another key point. Let's see what people are kind of pointing out in the chat room here. Right. So let's see, stable, scalable, secure, modular. Right. So one aspect of it is the security and stability aspect, right? So stable in the sense that you can have a Linux computer such as iLab, and you can have pretty much thousands of students and faculty and researchers all logged in over the course of months using it for their projects, and the essential system of it will be stable for months and months at a time, right? This comes from just kind of the conservative nature of how its code is developed and updated, and how it kind of focuses on being a stable platform for computer science, right? And so you find it being used in all kinds of form factors, right? Ranging from extremely small computers, watches, Raspberry Pi, Internet of Things kind of devices, your Chromecast, Roku, those kind of media devices, if you have them or use them, or are likely in some way based off of Linux. The Android phone operating system is an extension of Linux. We have laptops that are based off of Linux. The iLab systems are based off of Linux. The whole internet, right? So major components of how internet web services are hosted, websites are all hosted on Linux systems. And all the way up to industrial settings like data centers for Facebook, for Amazon, and Amazon AWS, huge components of its infrastructure are all based off of Linux, right? So being familiar with Linux and at least starting to use Linux as this kind of first step is a critical step in being a practicing computer scientist, right? And if this is something that you're particularly fascinated about, right, the next steps to take in this direction beyond CS211 are CS213 systems programming. And then from there, we have a dedicated operating systems class where basically you learn to hack at Linux, right? You figure out how the underlying components work and you write extensions to it. Okay. So what we'll do next after kind of this introduction and motivation for why we put ourselves through this in the first place, right? So far it seems like we've been pretty comfortable with using Windows and Macintosh our whole careers. Why do we put ourselves through this challenge of using Linux? Well, so I just gave you the overall reason. Before I kind of launch into this next little segment about the first steps to get started, let me just take a check on the chat box here, just so that make sure I'm not missing something that's urgently needs to be addressed right now. Okay, so what I'm going to be giving here is very high level tips and pointers on getting started, right? Everybody has a different laptop and desktop setup. Some of you use Macintosh, some of you use Windows, different versions of Windows. Some of you have prior experience using Linux or using iLab, and some of you don't, right? So there's no one way for me to give you a exact checklist instructions on how to get started with this, but our department offers really excellent guides, right? So the first step here is you'll want to activate your account. Right, so if you're registered for this class, you should already have access to iLab. But prior to logging in, you need to set a password, right? So the link to do that is from here. Typically, you log into iLab using your NetID. And then you'll want to set a separate password just for the computer science systems, which can be the same as your new university password or separate from your university password, right? So the instructions here lay out exactly how to set that password so you have your iLab account set up. Okay, so the other big piece is that as you take classes with the CS department, it's really important for you to be familiar with everything or most of the things that's offered here from the CS department website. And under resources, you can go to technical support and services, right? This is where all the really good go-to guides for using iLab and how to use the programs on iLab all live here. right? So this is pretty intimidating at first, and that's for sure. But the beginner's guide here, linked here, gives you pretty concrete steps to take, right? So these are multiple articles, right? So starting from here, there's like an overview of what Linux is. And then relevant for our purposes on starting this class, you need to be able to take care of basically 3 steps, right? So number 1, you have to access a terminal to get to Linux. It's this step here. And again, I can't give you exact detailed like instructions on which is the best way to go about this. There's several ways that you can do this from Windows. You can either use the existing command line from Windows, starting from Windows 10 and above, or you can use PuTTY, right? So for Windows systems, those are the 2 typical systems to get to the command line. From Macintosh systems, the Mac OS comes with a terminal that I'll be demonstrating using, right? Because I use a Mac laptop, and that's what I use, right? There are also now several options for graphical access to the systems, right? So we'll come back to the computer science page here. Under this remote access section, there's at least 4 different ways that you may go about this. There's this new way where you can go and log into the systems graphically. Right, so this is purely from the browser, and from the browser window, you'll actually see a graphical login to iLab. That's one way. Another common way is to use X2Go, right? So if you're familiar with using and more comfortable using something that's like a graphical desktop interface, this is another way that students have gone about it, where you use X2Go, and again, it'll give you a graphical access to a Linux system. Okay, so those are the kind of high-level pointers that I have for getting to the access, and then the next couple steps are about accessing and moving files and editing files. I'll take a pause here just to take a look at the chat box, and I'll open up the mic for maybe a couple minutes if people want to ask something questions right here.
Professor. So
sure, go ahead.
what we're changing up the account on the site where account management tools for computer science systems. When we activate our NetID, that's all we have to do then to access the iLab once we activate.
Right. So activating the ID is like setting up an account, right? So after you've activated ID, the iLab computers know that you exist as a student who's taking CS211. And then you've got to pick one of the command line or graphical ways to access iLab, right? So if this is very vague, this will be a little bit more clear if I do this quick demo showing what I mean by that.
Okay.
Okay, so right, so let me make this a little bit more concrete, right? So this is specific to Macintosh computers. For Windows, you'll probably be using either the Windows command line or PuTTY. But for me, I go to terminal, right? So this is the command line terminal for Mac OS. From here, right now, I'm logged in on my laptop here, right? So Mac OS is Unix. It's a similar type of thing to Linux. You know, all computers have this access to the command line. But right now, where I am right now, I'm just locally here on my own laptop, right? So I can go to the root directory, and here all of these folders and files, these are local to my laptop. What I mean by accessing iLab is I want to move this command line from here accessing this computer to interacting with the department, computer science department iLab machines. Right, so to do that, I need to set up a remote access. the way to go about this is to use SSH. So SSH stands for secure shell, right? So shell is this term for when we have this command line, this kind of textual interface to a computer, right? So this is a shell. And one of the protocols that is common now is secure shell, which allows you to connect to a remote computer. And the arguments that you need to give to secure shell are who you are and what machines that you're going to access, right? So who I am YH804, this is my net ID. And the machine I want to access is at the iLab machines on the computer science, in this computer science infrastructure in the CS department, right? So these machines, they have names. One of the names or one of the computers we can use is iLab at cs.rutgers.edu. Right, so this is one of the computers specifically located in the computer science department at Rutgers. And when I hit enter, it will go onto the internet, look for where iLab at cs.rutgers.edu is, like who is this computer? It finds that computer and then says, okay, is there this person, YH804, on that computer? There is, and then asks me to authenticate, right? So it asks me to provide my password, which authenticates me that it's really me trying to get to my account here. And this password that I just entered here, this is the password that you need to set at the account creation step, which was here, right? So the account creation, you set the password, and now you have a password that you can use to log into iLab. Okay, so maybe let's take a look around, right? So here we are on iLab. Right, so this is a Linux machine that students taking computer science classes all have shared access to. It's got a file system, just like your computer has a file system, right? So here is the root directory for the overall iLab machines. A lot of these are operating system folders and directories. You yourself have a home on this machine, right? So you have a corner of the file system on iLab, which is where you can store your files, right? So in Unix systems, you type cd, will take you back to your home directory. And from here, you can use ls to take a look around. And here are your personal files on the iLab machines, right? So if you put files here, these will stick around so long as you have a account with iLab. All right. So I think that's kind of like the really express tutorial through where this all fits in. Okay, so again, I'll take a couple minutes here to just kind of take open questions. If there's something that I can say specifically in the time we have to make this a little bit more clear, I'd be happy to do that. I see there's a lot of activity on the chat box here.
Just saying, this is really cool.
Yeah, certainly, it is very cool, right? So from this terminal, you have the power of all of the invested infrastructure of the computer science department, right? And this gives you access to storage space and compute power that is far beyond what you can muster on a personal laptop. Okay, so. Yeah, I heard one more question coming in.
Yeah, on the terminal, when I enter like my net ID at the ilab.cs.rutgers.edu, on the terminal it comes up, it says, I don't know if you know what this is, but it just says the authenticity of host ilab.cs.rutgers.edu can't be established. And then it just says
you have to type yes.
Yeah, for that you should say yes, right? So that is a kind of it's like a security signing token, right? So it's basically saying that you've only you've never signed into iLab before, so your laptop doesn't recognize whether or not you're connecting to the genuine iLab. And so you basically have to say, yeah, I know what I'm doing. I'm connecting to iLab. Let's go with it.
I got it. Thank you.
There's a few questions in the chat box about the SSH command. So if you know the SSH command, help your fellow students out and type the command out there again.
Professor,
yeah, there you
go. When you log in using the command line, you said that like basically we're moving the command line from our local computer to the iLab machines.
That's right. Right. So
okay.
when I completed the SSH command, I went from controlling my computer to now controlling my account on the iLab machines.
Okay.
Okay. So another thing that you'll have to practice while doing all this is, what are the essential commands for doing some work on a Linux machine? And for that, one go-to guide is here on our module section. Under supplementary material, there's a PDF here of some basic Linux commands. Right? You don't have to memorize this, right? But it's a good go-to reference of seeing how to do something specifically. And I'll try to call out specific commands I'm using while doing the demonstration of the programming assignment today. Right, so this is posted on Canvas. Okay, so I just went through kind of a quick tutorial on how to get to the machines. Your environment will vary from mine. And so it'll take you a little bit of time to kind of try these different approaches and see what you are most comfortable with. Beyond getting to the machines, the next part, what we have to do is you have to move files, right? So move files, what I mean by that is we've got files here on my laptop, right? So I have a file system on my laptop. I have my course notes stored here on the laptop. I have stuff on my own file system. And on the other hand, the iLab machines are in the CS department. They're far from here. And we need to have some way of coordinating and synchronizing files if you need to move files back and forth. Right, so there's a couple of ways to go about this. One is SCP. All right, so maybe we can do a quick demonstration of SCP here. So I've opened up a new terminal. Sorry, maybe I should make this more clear. Let's split this window. All right, so on the left-hand side here, on the left-hand side here, I've got some files. So this is my left-hand side here. I have my laptop. This is, you can see I'm connected to my MacBook here. And what we want to do now is we want to move files from my laptop to somewhere on the iLab machines. So the way we can do that is via the SCP command. Right, so SCP stands for secure copy. So CP means copying files. SCP is a prominent protocol now for moving files around. And suppose that we are not familiar with exactly what the syntax for SCP is. Well, that's okay. You can just type SCP. It will give you a quick tutorial of how to use it. And the key options here, right? So the brackets indicate that these are optional flags that you could or could not provide. And then the last ones here that are not in brackets are source and target. This is what you need to tell it to move files from one computer to another. Right? So I can say SCP. And here I have some options, some files that I have here relating to the class. I have the modern C.pdf textbook, right? So this is a textbook we can download from the modern C book writers. And I then want to copy it to some target destination on iLab, right? So what I can do there is I can say YH804 at right. So what I've tried to do now, double check this syntax here. Right, so let's see where it tells us to do SCP. Let's see if I double check this. Yeah, okay. So here on the documentation for SCP here, it's saying SCP from your file locally to the destination computer. So user is YH804, my identity, at the remote host. And then from there, you can say a destination directory. Right, so by default, I want to move it to my home directory. Home directories are designated by tilde here. So that's going to do that again. We'll come back to our home directory on the right-hand side here. Now this is my iLab account home directory. And we can see that here we have, with the modification date of just now, 2/37, it's copied over the PDF from my laptop over here to the remote directory. Right, so this is one way to go about moving files between two computers, right? So I've mentioned here, we've got SCP. This is kind of like the bare basic, most manual way. Another approach is you can use a FTP program, right? So these are graphical applications that you can use to connect between computers. I personally use CyberDuck, which is available for Windows and Macintosh. Right, so in these kind of graphical environments, typically you have a list of servers that you have access to. I've configured iLab to be one of the defaults, so I can just double click it. And after double clicking it, it takes me right to my home directory on the iLab machines. And now I can browse all the same content on the remote machines, but now in kind of this operating system graphical view that you may be more used to. Right, so as you see here, now I've also gotten that modern C textbook now on the remote end. This was copied over just now from SCP. And you can do things like you can say, I want to, right click and open and preview, right? So this is kind of a roundabout way where I moved this copy of the textbook from the laptop to iLab, and now I'm opening it again using CyberDuck. Okay, right, so this was kind of yet another kind of quick tutorial through what you need to get set up in terms of having an environment to move files around. I'll take another couple of minutes to just take questions here and also to take a look at the chat box to see if there's something urgent that we gotta get through.
Professor, how exactly So after logging in, I was struggling with that for a little bit. How exactly do you display the directories again, where you were able to find where you're putting the PDF?
Yeah, so once you've logged in from terminal and you've gotten to, you're logged in, showing that, this command's going to your account at one of the iLab machines. From there, if you want to see what's around, you say ls, which is list directories. And so this will give you a view of the files and folders that are in your home directory.
So you just type ls, or?
Right, just type ls.
When I do that, it just prints a new line, but there's no directories listed.
Okay, so another command that you'll want to use, I don't know exactly what you're looking at, but another useful command for a situation like that is called pwd. So pwd means present working directory.
Yeah.
And pwd tells you right now, this command, right, where you are in the operating system right now is in this directory called common home your net ID, right? So this is by default where all of our home directories are located.
Right, yeah, that's what I have as well.
Yeah, so if you're seeing a complete empty ls, then it's very likely that you simply just don't have any files that are listed there yet. Right, so you're starting from a brand new account, and it's not surprising that's empty.
Okay, so it's supposed to be empty to start. Like there's not supposed to be anything.
Right. So in the chat box here, Archisa says something that right in your directory that you are in right now. One thing you can do is you can say touch, which will create a new file. So it's like create a file handler for a new file, and you can say I want a new file handler called zzz.txt. Right, so it'll see that zzz.txt doesn't currently exist here in this directory, and so it creates a new file called zzz.txt, and now you have this new file that you can manipulate, work with. All right, so let's move along now, right? So we connected to iLab. We've also, the next step beyond that is to get a comfortable environment where you can move files around. And then the next thing, what you need to do is you need an environment from which you can modify text files. Right, so again, this is one of those, there's no right answer, nor can I provide you a really, concise tutorial of how you must go about it. Right, this is a working skill that you'll develop in this class, which is you need to have an environment from which you can modify text files. So just now we've created a text file called zzz.txt. And right now it's showing it's 0 bytes large. I just created it just now. It's 0 bytes large. It's completely empty. And suppose that I want to write some text into it. Right, so one common way to do this on Linux is to use Vim. So Vim is a text editor, just like TextEdit is, just like Notepad is, in some sense, just like any kind of text editing environment that you've used throughout computing. Vim is one pretty powerful one available on Linux. And we can say, I want to edit zzz.txt. And here we are, it's open zzz.txt. It's completely empty. And so Vim has kind of all these specific to Vim moves that you can do to edit files. And all I want to show here is, well, you can use them to edit files, right? So I'll insert some text here. And I can say now save the file and quit from Vim. And I can ls again to take a look at what's here in this directory. And now it shows that there are 13 bytes written to zzz.txt. And those 13 bytes are the text that I just written to it. We can look at files by saying less, right? So I prefer using less to look at files. So less is another command. Less is a command that allows us to take a quick look at files. And so I can say less zzz.txt, and it'll give me a very short quick look at zzz.txt, and there it says the text that I had entered just now. Right. This is just one way that you go about it. Vim is, of course, a massively powerful tool to edit text. There's a lot of ways to customize it and add plugins to it. Again, the key takeaway is you need to find a comfortable environment from which to modify text. We'll come back to the slides again, right? So here's some collected ways that we can use. Vim and Emacs are two pretty powerful editors. There are also other text editors. So for example, you can say gedit. There's gedit. Okay, there is no gedit. We'll come back to this, right? So this is another way that you can consider if you want a text editing environment. Let me go to another way where you can use the FTP program. Right, so we come back to CyberDuck, which is the FTP program that I showed you before. Another way you can edit text files here is this is a graphical interface to the file system. And from here, you can say, I want to edit text files, for example. So you can right click, download, upload files, or you can say, I want to edit it. And here it's opened up zzz.txt for editing. And here I can say, hello world again. When I hit save, Apple S, or I say save this file, this will save the file onto my laptop, from which the FTP program will see, aha, I've made an edit locally on this file, and it will synchronize this file over to the remote end onto iLab. And so now I can come back to iLab, and I can say, let's take a look at zzz.txt again. And there you go. The edits that I made using a text editor on my laptop here has been synchronized over to the iLab machines. Right, so this is another way to go about it. Okay, so let me pause here again for another couple minutes to take questions on this third step, which is you need to have an environment that allows you to edit files.
If you wanted to do that second approach, but via the command line, so if you want to like open your text file in another application, how would you do that? Because like the first time you open the text file within command line, if I'm not mistaken.
What do you mean by the second approach?
Oh, like basically like the first time when you were editing the text file of like hello world, you did that within command line, I think. And then the second time you made the edit within another application using Atom.
Sure. So let me just go through how that did that again, right? So this the CyberDuck, which is a FTP file transfer program. Right now, it's already logged into my home directory on iLab. From here, you can right-click these files. There's all these ways to interact with it. One way is you can tell it to, I want to edit this file from a text editor. So my text editor here, I use Atom. You can also use Sublime, TextEdit, any other environment. From here, you can say, do your edits. And when I hit save, right, so I hit save file here, the save onto the local laptop here of this copy of the file will be synchronized over by CyberDuct to the remote end to iLab.
So like currently right now, there's 2 copies of the file, one on the local end and then one on the iLab's computers.
That's right. So this is kind of a subtle point, right? So where your text editor is located, that ultimately is where exactly the editing takes place, right? So here, it seems like I'm doing I'm doing the same task via 2 basically the same approaches, but the fundamental difference is when I do vim zzz.txt and this command line, the program, the environment from which it's editing the file, all of that takes place on iLab, right? So all of this editing is being coordinated by the iLab machine.
Okay, and then can we change the application that the iLab machine is using?
Sure, right? So you can use any program you wish, really. There's the main ones are Emacs and Vim to edit files, right? So if you wanted to use something else, then you can say Emacs zzz.txt, and that will do that in Emacs, or you could say, I don't know what other ones are. I think there's like, yeah, I mean, the main ones are Emacs and Vim, basically.
Got it. Thank you.
Sure. There's also Nano. Let's see if Nano is installed. Yeah, so there's Nano here. Right, so these are all text editors. Right, so any of these options, Vim, Emacs, Nano, the editing takes place on the iLab machines. And if on the other hand, you open it using a text editor on the editing actually takes place on your laptop, which is kind of tricky because you need to basically have an internet connection for it to synchronize your files from the local laptop over to iLab. This is just something tricky that you have to pay attention to. Okay, so we are now through these fundamental setup steps. Let's get started with a little bit of coding. Right, so let's look at code now. And again, so these key steps, right? So I'm not able to give really detailed instructions on how to do this. So you can, if you're stuck on something, Piazza is the best way to seek help, right? So from there, your fellow classmates can give pointers, the TAs can give pointers, I can give pointers. And there's something that you can't figure out via Piazza. The next best option is to use office hours. Right? The least best option, right? The most discouraged option is unfortunately to email any of us, right? Emailing the TA or emailing me. If you do that, most likely we'll direct you to post the questions to Piazza so we can work on it in kind of like a public way where everybody gets to learn from the question. All right. So let's move on to our programming assignments. All right. So here, some admin things, right? So the programming assignments are on Canvas. So from Canvas, again, under modules, under our first chapter here, data structures and algorithms in C, compiling debugging programs in Linux. Under the subheader programming assignment, a piece of the force programming assignment 0 is now published as of this morning. And here it gives you instructions on how to get going, what's our main learning goals. The main learning goal here is for you to get comfortable with Linux, compiling, running, debugging your program, and to get familiar with the programming environment, the infrastructure that we'll be using in this class throughout. As always, start early, use Piazza, recitation, and office hours. There's also the cave department kind of working space, which is currently closed for in-person use, of course. But just like before, the code red kind of work sessions are ongoing, right? So the details for cave and the resources they offer there are here on this page. The way we're going to get set up here is you will need to get the files for this assignment. And for this class, we use GitHub, which is a software development website. It's a repository for a lot of source code used by all kinds of organizations, right? So what you'll also have to do is go to github.com. If you don't have an account, you'll want to create an account. And from here, the repository for the source code and the grading infrastructure is hosted in this repository here on this repository. Okay, and the way that you can get those codes from GitHub onto your Linux account, onto your iLab machine, is via a git clone command, right? So git is let's do some demonstration here. So what we want to do first is we'll want to go to a directory that we want to work out from, right? So for me, all the files I put for the class is in my teaching directory. From here, I have several courses of directories. So you'll want to copy this directory here, 2022, spring semester 211, into a directory where you can put it on iLab. And essentially what you do is you clone the whole directory directly from GitHub onto the iLab machines. So I'll demonstrate doing that now. Okay, I'll get a new copy fresh from GitHub. You can take this command here, copy it onto your pasteboard, paste it here. So this command will go log into your GitHub account and obtain a copy of this repository onto this machine here. And so one other way to go about this is when you're at the GitHub website, you can click on the button here that says clone. And this here gives you exactly the command to paste to initiate this copy. Right? So click here. What you can do is paste that command here. And that will get your a copy of the files down into here. So now I have a directory called 2022 Spring Class 221. We can move into that directory. We move our working directory into that directory there. We type ls to take a look around. And as you'll see here, now we have all the files that are in the class repository, programming assignment 1, and the files are located here. Okay, so that was a lot of kind of steps that I just showed. Let me take a pause here for a couple minutes and again, take a look at the chat box and see if there's something that I can clarify. Okay. So I see one important question here, which is why are we doing this again? So why are we using iLab to run these programs when we could, right? Technically, you could do this on your laptop, right? So the reason that we're using iLab twofold, right? So one is for you to get practice using Linux. And the other reason is from kind of the content perspective, right? We're dealing with programs that interact at the hardware software level. And because these programs are going to expose how the hardware operates, it's important that you run these programs on machines that we understand, right? So we're going to be grading your assignments using iLab to make sure that you get results that only come from running it on the iLab machines, right? So essentially, if you run it on your laptop, your program may give some results and it gets 100%, you know, just from the grader script. But because it ran on your machine, the behavior is slightly different from running it on the iLab machines. And right, so when we grade it, the script is going to give you a different grade. That's why it's important for you to be doing this work on the iLab machines.
Professor, I know this is kind of a late question, but what exactly is Linux? Is it a operating system or like something else?
Yeah, so the question here is, what exactly is Linux? Linux is an operating system, right? So what is an operating system? An operating system is it's like a foundational infrastructure piece of software that coordinates most of the activity on your computer. Right? So you're looking at this from a laptop or a desktop screen. If you're using a cell phone, the cell phone is also running an operating system. What the operating system does is it keeps track of all of the activities that it's running, right? So a laptop, a cell phone is running a bunch of programs at once. You have your browser, you have a messaging program, you have GPS programs, maps, and so forth, right? All of these programs have to be coordinated by an operating system so that they take turns running. And major ones for kind of desktops and laptops, right? We have Windows as operating system, Macintosh, Mac OS is operating system, and Linux is a different kind of operating system that kind of operates at all these different scales. So you'll find Linux is a kind of operating system that you can find in really tiny devices, like embedded systems, right? Probably some vacuum machines run Linux these days. All the way up to huge supercomputers, they also run Linux. And so it's a kind of operating system because it's so important and pervasive through computer science, it's important for you to be familiar with it.
Okay, so that's the reason why, like, since you guys are grading the assignments using the Linux operating system, if we tried to do our programs on our own, like separate operating systems, even though it would work on ours, it wouldn't maybe like not work on the Linux operating system.
That's right.
Got it. Okay, thank you.
Okay.
Professor, I have a question.
Sure, go ahead.
So I understand how we're like moving and editing the files on iLab and stuff, but how do we like actually run the programs or debug them, since we want to do it on, we want to do those remotely and not on our own laptops?
Very good. So that will be our next step, right? So actually running programs. We'll get to that maybe like in a couple slides, but yeah, we'll be writing and running, building the programs on iLab shortly. Okay, back to the slides. So the slides, what we've done so far is, yeah, somebody's pointed out this text here is wrong. This is 211, not 221. I'll fix that shortly. We've copied files from GitHub, right? And what's nice about GitHub is throughout the semester, I can continuously update files, add new assignments to the GitHub repository. And this is, in our class, that's useful for adding new assignments, but, in the world generally, right? So you have all kinds of open source projects, which all use GitHub to save all the versions of their source code and allows multiple people to access the source code from a same location. I want to just use this moment here to kind of give a preview of the plan for these programming assignments. Right. So one important thing I want to do for the beginning of the semester here, especially because it's also kind of an abnormal start to the semester, I'm breaking what would be the first assignment into two separate steps. Right. So we have kind of a half step of PA0, which is your opportunity to get familiar with the environment and get that set up so that you can go on to tackle the rest of programming assignment 1. Right, so we'll take 10 days here to make sure everybody is up to speed on the environment. And this is worth just 2% of the course grade. Right, so the first programming assignment, it's a programming assignment just like all others, but this has relatively less weighting of the course grade. And this is so that you have the opportunity to work through kind of your environment without, immediately worrying about, getting all the marks you need on this assignment. The rest of the assignments, right, PA2 through 6, these 6 assignments, each of them will be worth 14% of the course grade. And generally, they have 2 weeks of work time from when they're released to when they are due, with the exception of PA4. So this one bridges across spring break. And so this is allocated 3 weeks of time. And so you can add these up. This is the 77% where the programming assignments count toward the course grade. And then the remaining 23%, those come from the collection of quizzes. So what we're working toward right now is modifying and compiling and running our first program. Right? So before we talk about that, just kind of another motivation point of, so why are we doing this in C? Right? So everybody's taken 112 up to this point, and 111 and 112 both are in the Java programming language, right? And if you've also taken some programming classes prior to 111, oftentimes Java is also the teaching language in a lot of settings. Now, programming is not Java, right? Nor is Java all of programming. And in fact, Java is kind of a small portion of the wide world of programming. And then programming is also not computer science. Programming is just one aspect of computer science. And so the reason that we study C, yet another programming language, there are several reasons, right? So C is a very important language. It's arguably the most important programming language. It's been around for a very long time. And it is old. And because it's been around for a long time, it underlies a lot of systems. And also it's a relatively terse language, right? So the full description of what goes into C is relatively a small description. And so we have textbooks like Modern C, which provide a kind of concise overview, like a comprehensive discussion of what's the specification of C. So in terms of its purposes here, right? So C is, it being kind of this older language, it exposes a lot of features about the hardware, right? So what we mean by that is when you program in C, the actions that you can take, they directly correspond to actions that the computer will do to execute your program. This means like the actual instructions that run on the CPU, the moving of data around in memory, all of this is somewhat exposed directly in the language. C, just like Java, is a programming language that's going to be compiled, right? So when you run a C program, when you want to run a C program, first of all, you have to take the source code and run it through a compiler, which analyzes if this program is valid. And then if it's valid, then creates a actual assembly code for your program. We'll see exactly this being done in a short bit. And so this is similar to Java, where when you program a Java program, you write a .java file, and then you send it through a compiler, Java C, which will compile your Java program into the actual bytecode, a kind of compiled program for running on the computer. All right, so these are kind of different properties of C, right? Some of this may not be too familiar, right? So typing, for example. So this is another aspect of computer systems, right? So in it, beyond CS211, we have a class called Principles of Programming Languages, where you kind of study the properties of languages, right? So there's many kinds of languages. They offer different capabilities, right? And in some sense, just like natural languages like English and Chinese and Hindi and German and Japanese, right? The way that the language is constructed strongly influences the way that you think about constructs, or the way that you can phrase and communicate certain things. There are some things that you can easily communicate in one language and some that cannot be. So it's the same thing with programming languages. Different properties of programming languages allow you to do different things. And C is the programming language of architecture. It's the language of computer systems, right? So if you're doing programming on operating systems, on computer networks, all this is going to be done in C. Right. I also want to show you just one more kind of really cool thing. So there's this website called TOB. So TOB is this, I guess it's like a tracker where they analyze all different kinds of source codes. Right? So some on GitHub, for example, where they look at what are the programming languages that are being used the most frequently. Right? So these days, Python is the go-to prototyping language. Right? Python is the language of AI, of machine learning, of data science. And so these days, Python is this really high level and expedient language that allows you to accomplish a lot of tasks very nicely. C is currently second place, right? So not long ago, it was first place. And C, despite it being ancient, has held these top 3 spots forever. It's not going away. And it's because C, like I said, is the language of systems. It's the language of operating systems and networks and architecture. From there, you have all your variety of other important languages, right? So everybody knows Java, and Java continues to be the language of business. And it's a very robust language. It offers a lot of features, and it offers its own kind of sets of capabilities too, right? So come take a look at this. There's some languages that you may recognize, like MATLAB is a language for a lot of scientific analysis and so forth. Right, so hopefully this is just to motivate that C is a useful language and it's influential in the world. So from here, I'm going to give a quick kind of pointer, or kind of like a just like explanation of what's going to happen next. Right, so the way I go about teaching C, what you need to know about C to do the programming assignments is via examples, right? So I'll walk through examples, modify the code, run the code, so that you can see what I see when I program, when I write C programs, right? And that's not a substitute for kind of other important sources, right? So you also need to use a reference material like Modern C, where it will kind of go through and do a comprehensive walkthrough of what's going on. Some of the material, you'll have to use the internet, right? So there's a lot of references about like exactly how a function call looks, what exactly a error message means. Those are things that are best handled. You have to go search for what you see, search for the function call on the internet, right? So there's like cppresource.com and so forth. What we'll do here is you'll watch what I do when I write these programs, and I'll walk through what I see and what are the different pieces of the code and how they influence the program. And then also, of course, there's more steps, right? So you're going to practice it by doing the programming assignments and work through, all the things that you haven't memorized yet in terms of, it's the first time you're going through it. And so you'll have to, learn what you don't know, right? So this is the best way to go about actually learning the language and using it. And then also, finally, an important part is you'll also interact with your students via Piazza when it comes to kind of going through different steps, right? So I should caveat this. This doesn't mean showing your friend what your code is, but instead you can discuss things like, okay, I run into this error. What might be the kinds of bugs that lead to that error? All right. So let's see. So we've gone through kind of a motivation of what C is, and also how we're going to go about studying this. So I've got a few minutes going forward, right? So what we've mostly gone through, what we need to get through today is accessing the machines, right? Some pointers on accessing machines. And then I think what I'll try to get in the next few moments is compiling and running the program. So before I do that, let me just take 1 minute to take a look at the chat box and also take some questions here.
I just wonder if there's like a complete tutorial how we set up the whole iLab thing for our laptops, because I was kind of lost.
Okay, so the best sources for setting up your iLab environment would be from the department guide. Right, so the department guide here from this link, infrastructure, beginners info. Here, starting from here, right? So this step is the remote access aspect, which is actually going from your laptop and getting a connection to the iLab machine. So you can go through these steps of moving files and editing text. And so depending on what types of environments that you want to use, right? So you may want to use X2Go, for example. Right? So this provides a kind of walkthrough of what you need to install and how to configure it to do this. That's one way. Right? So, if you need kind of like one initial take on doing this, X2Go is probably one approach that you can try out. Right? It's not the only one, and I wouldn't say it's necessarily the best one, but it's one way to get started. Right? So this X2Go instruction page here, this is the detailed steps that you can try to go step through to get set up.
Right. So, so like I was just wondering, which one of them can I go through just to be familiar with the way that you just showed us, like the how do we access it with terminal, the whole thing?
Okay, so the one for that, right? So the textual way, let's see. right? So I think this may be one guide for doing that, right? So this will allow you to use a Windows client to do SSH. That's one way to go about it. But I would say that these guides here are the best go-to ways to get started.
Okay. Thank you.
So there's a few kind of pointers that I see that classmates are pointing to in the chat box too, and those would be good sources just as well. Okay, so I think specifically for today's lecture, I will post the chat log because it seems like there's a lot of really good sources that everybody also has access to. And that's another resource that you can turn to. Okay, so we are officially at the time stop, but I want to just really quickly demonstrate, get to kind of the key step what we need to do here, which is actually compiling and running your program. Right, so you can go to, once you're in this directory here, go to programming assignment 1. And I've created a demonstration program called oddEven. So it's a program that prints odd if a number is odd and even if the number is even. And from here, we have our source code in the C file. Right, so less is the command to take a look at the source code, peek at it. Right, so here is the C source code. And what you need to do is take this source code and turn it into a compiled program. Right, so the source code to turn it into actual program, the compiler that we use is GCC. It's the GNU C compiler or GNU compiler collection. It's this group that develops compilers. So you say GCC is our compiler. And just as kind of a first pass, you can say GCC oddEven is the source code. And this will take the source code and create a program. So it actually creates a file that is a program that you can run. And the way that you run that program is you say /a.out, and this runs the program. And this program specifically, it looks for a input, right? So I'll say a.out is our input. It says, tell me if the number 1 is odd or even. So we say a.out 1, and it prints out the program says it's odd. Right, so that's kind of a first step that we can take to take a source code, compile it, and run it. Right. This isn't going to be the end all of how we do this, but this is just kind of a first demonstration of doing that. Okay, so we're now 2 minutes over time.
Yes, sir.
So if you have to log off, please feel free to do so, but I'll continue to stick around and take questions.
I have a quick question.
Sure.
What you just demonstrated, is that like in Java where you have like the .java file and then you compile it and you get the .class file?
Exactly. So it's very similar, right? So the .java file is the actual text file that you can read. That is the source code. That's your program code, right? Something that you use to modify the text, and it says what the algorithm is. Now, that source code has to turn into something that the computer can run. In Java's case, you take the .java file and turn it into a class file, which is something that runs on the Java virtual machine. It's kind of this intermediate layer on which your Java program runs. Here in C, your source code gets compiled into binary code. So it actually gets compiled down to a sequence of zeros and ones, which is something that the machine will go in and use as kind of instructions to carry out your program. Right, so essentially, the short answer is yeah. So you take GCC, compile it into your source code. This is exactly the same kind of idea as Java C, a Java source code, and turning that into something that you execute.
Well, thank you.
Sure.
Excuse me, Professor. I was wondering when the first quiz will come out and when will the next quizzes come out, like every Monday, Wednesday? Thank you.
Yeah, so the quiz schedule, I'll announce it beforehand. In general, it's going to be when we finally get to like more kind of content, right? Kind of the technical, kind of like the conceptual ideas, or you start using quizzes to make sure that you're up to date with the material, and that'll be kind of quizzing basic concepts about the 1 or 2 weeks worth of material leading up to the quiz.
Professor.
Sure. Hi.
I keep having these weird problems where I can't clone the Git repository, and I tried like looking up the error it gave me, and it told me I need a token, and then I used the token as the password as it said online, but now it says that the GitHub can't be found.
Okay.
The GitHub link is actually named wrong. You have to use 221, not 211.
Oh, yes, yeah, okay. So I use what? 221?
Yeah, 221
Right.
at the end.
So
Wait,
I've seen a bunch of
should-
comments of that flying
It
around.
should
I'm
be
not
211, right?
Yeah, so
make sure you put
okay,
211.
I'll have this is my mistake. I named this the wrong name for the repository. So just hang tight. I'll be fixing this to get it the right repository name.
Okay.
Oh, if you're gonna
I-
change the repository name, will that affect the submission names and stuff like that?
Yeah, so I'll update, just hang tight. I'll update this name, and then the assignment instructions will also reflect the correct name.
Professor?
Yeah.
Just a quick question. So in the repository, I see programming assignment 1, but when you release files for the future programming assignments, is there a way to individually clone files from the repository, or will we have to reclone the whole thing every time?
So the way that Git works is so long as, right, so you can make some modifications to your own copy of the files, right? So you can, inside the assignment directories, you can have your own source code, colots.c, for example. And when you pull from the repository again, right, using git pull, right, what that means is synchronize your files from the remote repository, and it will get any new files that are in the directory and put them in your local copy, right? So in the future, when there's like PA2, you can say git pull, and it'll put the new fresh PA2 directory into your machine.
Okay, that makes sense. Thank you.
Professor, just to be clear, is programming assignment 0 just the assignment that we cloned right here?
No, right? So programming assignment 0 will have a couple steps, right? So one is, so in this repository right now, I have the demo program that I'll be walking through on Tuesday. We have the first piece of the programming assignment 0, which is this problem here. And so we haven't introduced that yet, but you can take a look at what the program description is, the assignment description is, and this is one of the steps for programming assignment 0. Right, so the focus is, right, the goals of programming assignment 0 is for you to work through these steps of getting your environment set up and then have some initial working experience and using the C language.
Got it. And programming assignment 0 is going to be due on February 1st, and then programming assignment 1 is going to be due on the 8th, right?
That's right. Right. So
Okay.
I've taken what would have been typically the programming assignment 1 due on February 8th, And I want to take this kind of short step first to kind of have a checkpoint to get everybody set up more quickly.
Okay, got it. Thank you.
Professor,
Yes.
where will this video be uploaded, like the class lecture?
Archisa, your voice is coming through very muffled. So either you can try talking closer to the microphone or maybe texting it on the chat box. Okay, Archisa's question is, where will be the lecture be uploaded? All right, so on our class web page, let me just switch to student view. So this should be what you see when you go to Canvas. And most of our kind of working directory, kind of our main environment for Canvas here for this class is in the modules page. And here you'll see on Tuesday's lecture, I have the Tuesday slides posted here, and then also the Tuesday lecture recording, which is hosted on YouTube here. This recording is available too, right? So this is where we keep track of all the class slides, and then I'll have the recording for today's session eventually uploaded here. Okay, all right. So yeah.
I was just wondering, is
Alak, go ahead.
CyberDuck like necessary to download for us to be able to run and compile all our programs?
No, it's not necessary, right? So first of all, you instead of CyberDuck, you could use FileZilla, for example. That's another big file transfer program. And if you don't want to use either, then you can also use SCP, right? So secure copy allows you to copy files from one computer to another.
I have a couple questions.
Yeah, John.
Yeah, so for programming assignment 0, it says it's 20 points maximum, but for COLLATS, the 3x+1 problem, it says 10 points.
Yeah, so I haven't finished kind of posting the entirety of programming assignment 0 yet, so I'm just saying type.
Oh, okay. Also,
yeah, I just wanted to have kind of this the structure up so that I can show you like where the things are all going to be.
Oh, okay. Also, under how to compile, run, and test your code, you said that once your program is successfully compiled, you can run your program using collats test/test0.txt. That directory doesn't exist. Directory doesn't exist.
This is on the instructions here.
Yeah.
Okay. Where are you looking at this?
Above. Yeah, right there. Collats test0.
Ah, okay. So this is wrong. So it should be you see the test directory in collats, right? So in the collats directory, the test directory, it should be /collats. Right? Assuming you've compiled your program, you would say collats test 0. That should be the correct command. The directory is called tests, plural, and the test itself is singular.
Okay. Thank you.
Okay, alrighty. So I'll go ahead and call it at that. Thanks for sticking around, and have a good rest of the day.
Have a great day, Professor.
Take care.
You too.
Have a great day, Professor.